Good morning, students. Today I'm here with class 12th, chapter number 5, lecture number 4. As we have completed the concept of continuous functions, now let us go to differentiable functions. So the first thing that should come up to your mind is, what do we mean when we say that a function is differentiable, or we are checking the differentiability of the function? So a question comes to our mind, what do we mean when we say that a function is differentiable at a point, let it be any point at C? So to explain this, we will take a function f of x, right, which is defined on an open interval AB. Let P is a point which is C comma f of C. Function is C f of x. So when you put x, that will be your domain, and f of x will be your the answer, that is the range. So here if you are putting C, f of C will be the answer. So if P is a point which is C comma f of C, be a point on the curve y equal to f of x. Let Q is a point. The value or the points for Q are C minus H and f of C minus H. Here H tends to 0. And another point R, which is C plus H and f of C plus H, be two neighboring points on the left and right hand side of the point P. So we will draw one curve y equal to f of x. We'll take a point P, and in its neighborhood we will take another 2 points which are point Q and point R. Right, so let us draw the graph and know how can it be done. So look here, drawing out a graph for you. Let us draw it. So I will take your y-axis and your x-axis. Okay, now suppose, let us name first. So let it be x, y, and this be your origin. Fine. This is your x dash, this is y dash. Now see here, I have to take a curve, clear? And the curve has a point P, and the points or the coordinate I say are C comma f of C, as already told. Another point R, whose points are C plus H and f of C plus H. Clear? Point Q, whose points will be or coordinates will be C minus H comma f of C minus H. So this is according to this, as I can show you, a curve has to be taken and these 3 points, right? So I have just done that. Now we will join point P to R and point Q to P, right? So joining these, we get 2 chords on the curve. The chords are PQ and PR, right? Now we will find out the slope of these. Let us write the slope of chord PQ first. Slope of the chord PQ. Now you know how do we find the slope? It is y2 minus y1 divided by x2 minus x1. Now coordinates of P, as you can see from the graph, are C comma FC, and coordinates of Q are C minus H and f of C minus H. So let us just write down the slope. So just to see here, P point is C comma f of C and Q point is C minus H and f of C minus H. So just see, when we are finding the slope, what do we write is f of C minus H, which is y2, minus f of C upon, you see what we will get, C minus H minus C. So the answer that we get for this is f of C minus H minus f of C divided by minus of h, as C and C gets cancelled. Similarly, we can write slope of chord PR now, which is the another chord in our graph, as you can see. Okay, let us write using the same formula. We know for R, the point is, or the coordinates are C plus H and F of C plus H. So using these 2 points, we will write the slope of chord PR, which is F of C plus H minus F of C divided by, as C you will write C plus H minus C. So you will only be left with H. Clear? Let us apply the limits to it. Limit H tending to 0. Okay, let us consider them as equation 1 and 2. Okay, now applying this to equation 1, just to see, I will write how. F of C minus H minus F of C divided by minus of H. Okay, what is it? We can write it as limit H tending to 0. This is what? This is slope of chord PQ. Clear? Now H tending to 0 means the point Q is very close to P. It is tending to P only. So I can just replace it. Say that point Q tending to P also shows slope of chord PQ. Clear? I can show you this by the graph. Just to see here, the point Q, it is C minus H. H is a very small value. That means it is a very close point to Q, to P. So Q is a point which is just in the neighborhood. Okay, or P, I say Q and R are the points, the neighboring points very close to P. So it is also giving this. Now as you can see in the graph, when the point Q becomes very close to P, or it actually approaches P, then this chord will become a tangent at this point. See, point Q will come here, then it will come here, it will come here, and at last at this only very close to P, a very minute difference. So you see this chord PQ will be lying as like this. Fine. So it will be becoming a tangent to it. So what I can write is, I can just replace this and say here that I can also write here about slope of tangent at point P. Slope of tangent at point P. Right. So what was the discussion? Let me now first revise it, what we have done. So I was telling you the differentiability of a function. For that, the question comes in our mind is, what do we mean when we say that a function is differentiable at a point x equals c? So we took a curve y equals f of x, on which we took 3 points. P is c comma fc, and in the neighborhood of point P we took point Q and point R, and we have drawn the graph according to that. Drawing the graph and then finding out the slope of the chord PQ and slope of the chord PR, that I have written here. Right, now applying the limit to it, we get the slope, or the chord gets converted to the tangent. Right, similarly it will happen to our slope of chord PR. Let us apply this. So now I will write limit h tending to 0 to our equation number 2. So limit h tending to 0, f of c plus h minus f of c divided by h. And this can be written as limit h tending to 0. This was what? Slope of chord PR. Clear? You can see in the graph. PR slope we have calculated and applying the limit to it. Now just to see, I can write it as limit h tending to 0, or as in the previous case. Now you know that point Q, let me show it through the graph. Q is C plus H, a point which is more than point P, or a value which is more than C but very close to C. Right, so I will write point R tending to P, that means H tending to 0 itself. So I will write that point R is tending to point P. This means slope of chord PR. This is limit is applied to slope of the chord. Now, when point R is a very close to point P, this results this chord will become a tangent at point P. Clear? Let this be your fourth equation and let this be your third equation. Now you see the third equation and the fourth equation are resulting in the same thing, that a tangent at point P. So I can actually equate equation 1 and 2. Right? So let us just equate them. So I'll just take a new sheet and we will write on that. So what are we writing? This implies that limit h tending to 0 f of c minus h, right, minus f of c divided by minus h, and limit h tending to 0 f of c plus h minus f of c. They both things are resulting in a tangent at point P. So they both are equal. That means we say at point P there exists a unique tangent. So fx is differentiable at point P if there exists a unique tangent at point P. Or in other words, I can say it as fx is differentiable at a point P if the curve does not have P as a corner point. The curve should not have a sharp edge. Just to see here one thing. If you have a sharp curve, right, and you have P as this point, so see we can draw n numbers of tangents on it. There can be many tangents that can be drawn on it. So it is not a unique tangent. So the curve should not have P as a corner point. So what do we mean by differentiability now? That if a curve or if a function is differentiable, at every point of that curve, there exists a unique tangent only. Fine. Let us now move to the definition of differentiability. Now, the point is, what do we mean by differentiability? For this, so I'm writing, see, the definition is, let f of x be a function defined on an open interval a comma b, and c is the point in this interval only. It belongs to the interval a comma b only. The function is said to be differentiable at point c if limit x tending to c f of x minus f of c divided by x minus c exist finitely, if this gives us a finite value. Clear? Or we have already done now that what is the meaning of differentiation. So this is actually known as the differentiation of function at point C, or I said derivative of the function at point C. This can be also represented by f dash c, or we may write it as d by dx of f of x at x equal to c, right? So these are just the representation, or one more representation, like we can write differentiation of f at point C. So these are just the representation, they all means the same thing. Clear? Okay. Now, so how do we check the differentiability now? Just to see, we will get limit x tending to c minus, what we were getting here, if I solve this, f of x minus f of c upon x minus c, you will get limit h tending to 0 f of c minus h minus f of c upon, when you write c minus h minus c, it will be minus h. And on to another side, when we write limit x tending to c plus f of x minus f of c divided by x minus c. So here we will get, when we change this to h tending to 0, we will get f of c plus h minus f of c divided by h. Okay, why I am writing like this? Because in the previous question what we have written, that in the definition we wrote that this should exist, this limit should exist. This means LHL and RHL are equal. So I have just equated the LHL and RHL, right? So now this one is known as left hand derivative. Clear? This is left hand derivative, and this is known as right hand derivative. As you have LHL, left hand limit, and right hand limit, in continuity, in differentiability, you will have LHD and RHD, which is a left hand derivative and your right hand derivative. Fine. If you prove LHD as equal to RHD, you say the function is differentiable, as we have seen already through the help of graph. Or if you get LHD not equal to RHD, we say the function is not differentiable. That means the curve, at every point of the curve, there does not exist a unique tangent. Now we will take one example to see how do we check the differentiability of a function. Right, let us do that. Now suppose in the question they are giving you a function which is f of x. It is given that when the value for x is less than 2, the function will be x minus 1, and when it is greater than equal to, the function is 2x minus 3. They are asking you to show that it is not differentiable at x equal to 2. So let us check how do we do that. So for checking the differentiability, you will check LHD and RHD of it. Okay, so I will just solve both the parts. See here how to write, because all the exercise questions are to be done in this way only, right? Just to see, for LHD you will write limit h tending to 0 f of c minus h minus f of c divided by minus h, and here you will write limit h tending to 0 f of c plus h minus f of c divided by h. Now what is c here? C is 2 here, correct? C is the point 2 here. Now LHD means less than 2 we are checking. Less than 2 means the function value is x minus 1. So what we have to check is first f of c minus h means f of 2 minus h. And for this 2 minus h, which is less than 2, the function is x minus 1. Right, so the function is x minus 1. Instead of x, we will put 2 minus h minus 1. So you see 2 minus 1 is 1. You get 1 minus h as the answer. Let us check f of c. Now f of c will be at, c means f of 2. Correct? F of 2 means at equal to 2. Let me write it for more clarity. F of 2. For f of 2, we will take this function. So 2 into 2 minus 3. That is 4 minus 3, which is 1. Got it? Now let us take the next sheet to just write. So what we are going to do is just place the values in this formulas, or what we can do is solve the RHD on the another part, and let us first solve our LHD only. Okay, just to see, we'll do this later on. Okay, just to see here, let us put in this the values. What do we get? Limit h tending to 0. F of c minus h, that means f of 2 minus h is 1 minus h, minus f of c means f of 2, which is 1, divided by minus h. 1 and 1 getting cancelled, correct? You are left with minus h upon minus h. They will also get cancelled. The answer is 1 for it. So I think LHD calculation is clear. Let us go for RHD. In RHD, what we were writing, that limit h tending to 0, we have f of c plus h and minus f of c upon h. That means we have to actually write f of 2 plus h minus f of 2. Instead of c, I am placing 2 upon h. Now f of 2 plus h. 2 plus h means greater than 2. So the function taken is 2x plus 1. So let me just find f of 2 plus h. What will it give us? 2 into 2 plus h minus 3. So you get 4 plus 2h minus 3. 4 minus 3 is 1 plus 2h. So instead of this, what will you write? Here, instead of f of 2, 1 plus 2h. F of 2 we already calculated, which is 1. You can see f of 2 we calculated as 1 only. Clear? Divided by h. Now 1 and 1 getting cancelled, 2h upon h and h will cancel. You are getting the answer as 2. In RHD you are getting 2 as the answer. In LHD we were getting 1 as the answer, as you can see. So LHD and RHD here are not equal. So in the next sheet I am just writing how you have to write. You will write as LHD not equal to RHD, hence the function is not differentiable. That's all you have to do for differentiability. So learn the formula for LHD and RHD and you are all good to go with the questions. Now the last concept is a chain rule. How do we do differentiation using chain rule? You might have done differentiation in 11th class also. So let us just discuss. This is a very simple concept. In chain rule, what do is we differentiate the functions one by one. That means suppose they ask you to differentiate, let me give you one example. Suppose sine of x square. So you see this is a composition of two functions as already done in exercise 5.1 also. It is a composition of two functions. One is sine x, another is x square. Now you will do, first of all you will do the differentiation of sine. D by dx of sine of x square. So as we know, differentiation of sine is cos of x square, as it is we are going to write. Now we will go with the differentiation of x square because we have done only for sine. So it will be written as cos of x square into of x square it will be 2x, right? And at x if we do that we get 1. So the answer is 2x into cos of x square. So this will be your answer. This is you are using a chain rule. That means the finding the differentiation of the function one by one. So I can give you one more example. So let us take the example as y is given as suppose cot of under root of x. Clear? So first of all you will be calculating or differentiating the function with respect to x. You will write d by dx of cot of under root x. Clear? So first of all differentiation we know is minus cosecant square. The angle is root x will remain as it is. Now we will do differentiation of under root x. Correct? Under root x means x to the power half, and d by dx of x to the power half, you know, you will take n in front and x to the power 1 half minus 1, which is x to the power minus half. So the differentiation of this will be minus cosecant square root x into 1 by 2 root x, and for x it will be 1. Clear? So this is how you are going to solve the questions of chain rule, the differentiation. Now in homework questions you are going to do exercise 5.2 and questions 1 to 10 all should be done in your homework notebooks. As I have explained one question on differentiability and chain rule also we have taken 2 examples. So now it should be really easy for you to attempt the exercise questions. So that's all for today. Thank you.